what we're trying to do is measure superheat at this residential split system. It's an R22 unit. Notice that what we've got so far is we've attached the manifold to the suction line and liquid line, and notice that we're going through these Schrader core depressing tools on both sides. Now notice also we have a digital thermometer that is attached, the probe attached to the suction line. Now what we should actually do is, to make sure that ambient temperature does not play a role in our measurement, we're going to put some of this Armaflex insulation, this suction line insulation, over the sensor. Alright, now, notice that what we have here is a suction line temperature of 63 degrees. 63, not 62 actually, it's changing a little bit, 62 degrees. Now the low side pressure, you can barely read it because it's not focused very well, but it's approximately 32, 4, 6, 38 degrees. R22, that's the green. Now if it's about 65 pounds pressure on the suction side, it looks like the saturation temperature is around 38 degrees, something like that. Close to about 38 degrees. Now if I'm boiling at 38 degrees, by the time I actually get to this point, right here on the suction line, I just put some electrical tape on the sensor. 63 degrees. 63 degrees minus 38 degrees, 63 minus 38 degrees, that is our superheat. And 63 minus 38, we don't know if that's good or that's bad. That's 20, what is that, 24 degrees superheat. But we don't really know if that's good or bad. All we know so far is this is how you actually measure superheat. You measure the suction line temperature after, of course, putting the low side pressure gauge on. Measure the suction line temperature. As long as you know what the refrigerant is. Can't focus. That's 24 degrees. 24 degrees of superheat. That's this one. That says 38. Of course, that's our high side pressure. R22, 38 degrees at this pressure. 62 degrees, that is our suction line temperature. The difference, of course, between our suction line temperature and our saturation temperature, that is superheat.